Hi guys, this is Miss Scott here. Thanks again for tuning in to my channel. Don't forget to like and subscribe to see more and hear more wonderful bad jokes of the day, like this one. What do you call a chicken looking at a pile of lettuce? Well, chicken sees a salad. Whew, which kind of sounds like chicken Caesar salad. Yeah, that one's kind of a stretch. All right, well, let's get into the lesson. So if you want to take a moment and pause the video, jot down the essential question and these two definitions, and then we'll talk about them in a moment. Okay, so we actually have two essential questions. The first one, how do you find the centroid of a triangle? And then how do you find the orthocenter? So we're going to talk about the centroid first. So in order to find the centroid, you need to know what a median is, which is a segment from a vertex to the midpoint of the opposite side. So say we have a triangle here, and that's the midpoint of that side. So a median would go from this vertex to that midpoint. So if that's the midpoint, that this little segment right here would be the median. Okay, and if you draw in all three medians in a triangle, which we're going to do in the example down below, it turns out that they meet at a point called the centroid. So I can kind of just draw a rough sketch of what that would look like. So we got this triangle here. Here's a midpoint, here's a midpoint, there's a midpoint. So if I draw on that line, that median there, and that median there, they should all intersect at this point, which we would call the centroid. And it turns out that's actually the center of gravity. So if I could cut that triangle out of the piece of paper that you're drawing on and balance it on the point of my pencil, it should be balanced at that point. All right, so here's a little example for you. So what you should do is just draw a triangle using a ruler on a piece of paper. And then use a ruler to find the midpoint of each side of that triangle. So you're going to measure each side, cut it in half, and put the midpoint there, and then draw in the medians. And then if you label your points like they have shown in step 3 here, and then we measure some lengths, we're going to see if we can come up with some sort of relationship. So I did this ahead of time on a separate piece of paper, and I did all my measurements in centimeters, and I found some lengths when I did that. So I measured and I found the length from A to D, so this entire median here was 9 centimeters long, and then from A to P was 6 centimeters, and from P to D was 3 centimeters. Okay, and then I did the same thing, let me do that in another color, for segment BF, so this median here. I found that the whole thing was 6 centimeters long from B to F. From B to P was 4 centimeters, and then from P to F was 2 centimeters. And then I did one last measurement from E all the way over here to C, and I found that this median was 12 centimeters long. From C to P, so from C to P was 8, and from P to E was 4. All right, and we're going to look at those numbers and see if we can find any relationship with the median's length and the location of the centroid. So it does turn out, maybe you're starting to see that relationship now, but it turns out that that centroid, or that point of concurrency, divides each median into a vertex side part that is 2/3 of the entire median's length and a midpoint side part that is 1/3. So it divides it into a third and two thirds. So like 3 is a third of 9, and then 6 is 2/3 of 9. 2 is a third of 6. 4 is 2/3 of 6. And 4 is a third of 12. So if you divide 12 by 3, you get 4. And then 2/3 would be double 4. So yeah. And we're going to use that fact to do an example down below here. So they tell us in triangle RWT with medians RU, TV, and WQ, if RS is 4, so that's on the picture here, SV is 2.5, and QW, so this entire length here is 9. We're going to find some facts. All right, so let's first start with SU. Let me just erase this other stuff so we can focus on that. So SU is here. And if we know from S to R is 4, and that's the longer piece, if you divide 4 by 2, that's going to give you the length from S to U. So this, you can find this by dividing SR by 2. All right. Okay, let's look at our next example here. TV, well, we know SV is 2.5, so that means from T to S, we can find that by multiplying SV by 2. So we can find this by multiplying SV by 2. So that means from T to S would be 5. And if we add that 5 and that 2.5, TV is 7.5. All right, lastly, SW. That one's going to be kind of tricky, but we can handle that. Well, they told us this entire length from Q to W is 9. So if we know QW is 9, we can take a third of 9, or 9 divided by 3, we get 3. So that means from Q to S is 3. So from S to W has to be 6. All right. Okay, so that's how you can use the medians to find some missing lengths. So now we're going to throw in some algebra here. And we're said to find the value of x if RK is 6x and RP is 3x plus 7 and P is the triangle's centroid. All right, well, RK, let's put that is 6x. Okay, and that's this entire median here. Okay, and then they tell us that from R to P is 3x plus 7. So that's just from here to the centroid is 3x plus 7. Well, we know from that theorem 5.8 up above that RP is equal to 2/3 of the entire length, which the entire length is RK. And we have some expressions for each of those. So in other words, we know that RP is 2/3, and instead of using RK, we can use 6x. That's the same thing. And 2/3 of 6 would be 2 times 6, which is 12, and then 12 divided by 3, this would be 4x. So we know that RP is equal to 4x. All right, well, if RP is 4x, and we also know that RP is 3x plus 7, I'm hoping you guys agree with this, but hopefully you agree that RP is equal to RP. Well, we have RP equals 4x, and it equals 3x plus 7. So we're going to say 4x equals 3x plus 7. And if we subtract 3x from both sides, we end up with 1x equals 7. Okay, kind of a tricky one here. All right, we're going to learn about one more thing, and that is the altitude and the orthocenter of a triangle. The altitudes are just like the height. So if you want to pause for a moment and jot these down, then we can talk about them for a little bit. Okay, so again, altitude, height. And that is just the perpendicular segment from a vertex to the opposite side. So if you had a triangle, for example, this would be an altitude. It's kind of just like how tall it is. So that's an example right there. And then the orthocenter is if you have a triangle, it's where the three altitudes intersect. And we're actually going to construct that down below. Okay, so the altitudes of a triangle all intersect at that point called the orthocenter. This is the only point of concurrency in a triangle that doesn't really have a lot of real life use. Like we talked about the incenter being the same distance to the three sides. We talked about the centroid being the center of gravity. This one doesn't really have a lot of real life applications, but we're still going to learn how to construct it. Okay, so to construct the altitudes of a triangle, you have to make 3 right angles to each side. It's kind of tough when it's in an obtuse triangle like this. The first thing you have to do is extend the sides. If you have an obtuse triangle, that's the first step, which in this case we do have an obtuse triangle. So I'm going to take and I'm just going to extend this side as far as I can. And I'm going to do the same thing with this other side. So the side that makes the obtuse angle, you do need to extend those 2 sides. All right. And I always just like to use the note card method when I'm making right angles. So hopefully you still have a note card handy. And we are going to start by taking our note card, spinning it so it's flush with, oops, I don't know why it just turned into a square. But we're going to spin it. If it wants to cooperate here, just wants to turn into a square. Okay, let's try this again. Doesn't matter if it's a square, but I want it to rotate. Very strange. It was working the other day. All right, I'm gonna get rid of this bad boy and try that again. All right, so we have a rectangle, and then we're gonna spin it so it's flush with one of the sides. I don't know, just really wants to be a square. Okay, so we've rotated it so it's flush with one side, and then we're going to draw a line from that side to the opposite vertex. So, there we go. This would be our first altitude, and make sure you extend that as far as you can, because it turns out that the orthocenter for an obtuse triangle is going to be outside of the triangle. So extend the line as much as you can. All right. Okay, so then let's take our note card and spin this around. All right. I'm just going to make a new square again, or a new note card. And then we're going to move it so it is flush with this side here. I'm trying to turn it. There we go. And then we draw this from this vertex to that side would be our first altitude. And again, you need to draw it. So that's going to intersect that first altitude that you created. All right. And then lastly, oops, let's erase that. I'm going to just keep making new note cards because it doesn't want to cooperate with me very well. All right. And then for this third side, okay, so we got one more side here to do this with. From that, and you can see it's flush with this side, right? So I'm just going to start by drawing this and then move it down a little bit. Okay, and we keep going so that it is going to intersect these other two here. Oops. So you can hopefully see that these were all created so that this is a right angle, that's the height from that vertex. This is a right angle, that's the height from that vertex here. And then this is a right angle, which is the height from that vertex. Okay, so those are our three altitudes, and they do intersect right here. And again, it does turn out that the orthocenter for an obtuse triangle is outside, which is kind of odd, but that is the case because a couple of the heights are outside. Like if you would consider the height of this triangle with respect to this side, this is how tall it would be right here. All right, so it was a little odd with constructing the orthocenter. It is a little easier to do on paper with like an actual note card, so if you're not sure what I was doing there, just come find me and I can show you using a paper note card. Alright, well, thank you guys for watching. Feel free to comment down below, and we will see you guys next time.